Hey everybody, I want to welcome you to week 4, module 4 for ME 144 heat transfer. So in this module, we're going to begin chapter 3. Now in chapter 3, we're going to be looking at is one-dimensional steady state problems there. We'll go through a couple practical examples and also go through some of my hand solutions to several example problems in this module as well. Now a couple of bookkeeping items. Your quiz number 4 has been posted and this will be due on Friday the 26th by 4 p.m. Also note, your homework 2 will be assigned on Monday the 22nd, and it'll be due on Monday the 1st by 11 p.m. at the end of the day. Now, as a reminder, I do have office hours set up on Mondays from 9 a.m. till 10 a.m. Now, if this time doesn't work for you, send me a message through Teams or a chat or an email, and we can set up a time that does work. On top of that, our TA also has office hours on Mondays and Wednesdays from 11 a.m. to 12 p.m. So between those 3 different sets of office hours, hopefully one of these times worked for you. And again, you can also email the TA directly as well. I would suggest using the TA's time for any homework related questions that you may have or grading related questions, as he'll be the one who is grading these. So as we begin module 4, this is going to relate back to chapter 3 in our textbook, looking at one-dimensional and steady state conduction. Now within this module, we're going to take a look at situations that heat is transferred by diffusion under 1D steady state conditions. So the term 1D refers to the fact that only one coordinate is needed to describe the spatial variation of the dependent variables. So this really does simplify down our solution and how we analyze these problems. And I think it's important to look at these 1D situations first so we understand what we're doing, how we're applying the problems, and then from there we can move into 2D and 3D. So in a 1D system, temperature gradients exist only along a single coordinate direction, and heat transfer occurs exclusively in that direction. So again, that really does simplify down our solution, really help us wrap our heads around what we're doing and how this is going. Within this module, we're going to take a look at the methodology of conduction analysis. Then we're going to break it down into the first section of this module, looking at just the planar wall. In the second section, we're looking at some of the radial systems, in particular, our tube wall and spherical shell. So our related readings in our textbook here, read along chapter 3, sections 1 through 4 in our textbook. So as I mentioned, we're going to break this module down into 2 different sections. In the first section of the module here, we have module 4.1. We're looking at conduction analysis for 1D steady state condition, in particular looking at the plane wall. So in this module, we'll look at planar geometries and some composite walls, analyzing the temperature distribution and heat transfer rate. Now breaking this down, what we're going to do is take a look at the plane wall, temperature distribution relationships, equations, and applications, some thermal resistance applications, how we deal with those, the composite wall, how we can set up a problem for that there, take a look at some practical applications, and then go through my hand solutions for a few problems that we'll work through together. Then as we move on to the second section, module 4.2, we're going to continue on with conduction analysis for 1D steady state conditions, but now we're going to take a look at some radial systems. So within this module, we're going to look at heat transfer with no internal generation of thermal energy and determine expressions for the temperature distribution and heat transfer rate in common cylindrical and spherical geometry. So now we're moving on to these cylindrical and spherical geometries as we begin this here. Activities within this module are going to include taking a look at the radial system for both the tube and spherical geometries, looking at the key equations associated with these, applying these key equations to some problem solving as we go through my hand solutions for a few example problems.